Cool, hi guys, thanks for having us. As you mentioned, we're from Intellect. So I'm Rishal. I work at Intellect as a team lead. My team basically work on anything. We're not technology specific, so we'll build mobile apps, web apps, .NET, Java, iOS, doesn't really matter. And Matt?
So my name's Matt. I'm a senior software engineer at Intellect, and yeah, I mean, like over the last year, I've worked on various projects, everything from Android to a little bit of C# stuff, even. So yeah, very multidisciplinary over there.
Cool, so the reason why we decided to do a talk on REST architecture is because we found a lot of people are confused about it. They misunderstand the point of it. And this is just through experience talking to clients, talking to developers at clients, and also peers at work. So the agenda for today, we're going to be going through a bit about general architecture patterns, an overview of HTTP, then dive into the REST architecture, talk a bit about message formats, then we'll get our hands dirty a bit with some code in building a REST service, and lastly, consuming these services. So with architectures, there's a number of different architecture patterns, and they all have their use and the purpose. So we're going to go through a few of them, one being client-server architecture. So you guys must be familiar with this. It consists of a server that does a lot of heavy lifting, processing a lot of requests, and there's various clients that make use of that. Important thing to note is that they need to have a standard protocol message that they both understand so that they can communicate. Another architecture is a layered architecture. You should be familiar with this as well. Typically, this is used within a specific solution. You'll have various layers, and you might have a layer that's shared. This could be a business domain layer, something like that. So that's also a possibility in a layered approach. Now, people often get confused between tiered and layered. A tiered architecture is very similar to a layered architecture. The difference is that each tier is located on a different physical location. So you might have a database server, you might have a business services server, and you might have a front end. All of these are on different tiers, however, within them they might have various layers. Then we have stateless. Typically with traditional web applications, a session is maintained. So when the client makes a request to the server, there's a state that the server manages for that specific client. In the case of stateless, this doesn't exist. Each transaction with the server is atomic, and the session is managed with the request and responses. There's no server-side handling of a specific session for a specific client. And then we have cacheable. So often with the internet built as it is, you've got clients making requests to servers via other servers, and what caching lets you do is cache some data that you know hasn't changed in various locations, and this is to improve performance. So in the case of this first client, when that client makes a request to the server and the data is cached here, it doesn't actually need to make this request to the end server. There's many ways to handle caching. So depending on the technology and your architecture, you might build it differently depending on your needs. The next one is the uniform interface. So uniform interface means that there's a contract that is abided by. So you're used to having interfaces in your code, and this is very similar. So in the case of a RESTful service, your uniform interface is a static set of verbs that you can use, and it works on URLs. So that's the interface for REST. Now, I went through all of these different architecture patterns because that's essentially what REST is built on. REST is an architectural style. It's not a definition or a standard, it's a style. And REST makes use of HTTP. So briefly going over HTTP, you have your protocol, your domain, your port, your resource, and your query. Often your port is not specified if you're running on default port 80. And yeah, so you querying a specific resource um, with that specific protocol. Now, HTTP also has a list of verbs that you can make use of, namely get, post, put, and delete, and they do your general CRUD operations. But there are a few that aren't really used that often. So one of them is patch. So patch is useful because you can just update one or two attributes of an object or resource that you're working with, whereas if you're using a put, you would need to upload that whole object, every single attribute in that object. So patch is very useful for making small changes to objects without having to send that whole object again. Another one is head. So head is exactly the same as your get. The only difference is it doesn't contain a message body. So you might be thinking, why would I use this? But this is very useful for validating information and saving on sending that extra data over the network. So if the client needs to determine if a specific entry has been expired or if it's still valid, you can make use of the head verb, and this would support that requirement. The next one is trace. Now trace wouldn't necessarily be used in a lot of production applications, but it's very useful for diagnosing problems that you may have. Now, when you're making a request to a specific service, this might be proxied through various servers on that chain. And you're not really sure what that last server is getting back because all these proxies might be manipulating your request until it gets to the end of the chain. So what trace does is it invokes a remote application layer loopback, and this tells you exactly what the server at the end of the chain received. So this gives you an idea of how you can diagnose what you're requesting and what the actual server is receiving. The next one is options. Options is useful in REST services because you can determine all of the different options available on a specific resource. So when Matt speaks about the maturity model, you'll see how this can be useful. So HTTP also has a list of status codes. 100 for information. This means a request was received and you can continue processing. 200 means a request was received, understood, accepted, and processed. So you want the 200s. 300s are redirection, so additional action is required from the client to complete a request. 400s means there was a client error, so that means the request that you were sending to the server was problematic. There was a problem with that request. And lastly, 400s is the request was fine, the client sent a valid request, but the server failed to process that for some reason. One thing to note, it's not okay to always return 200. Some examples. In the case of something hasn't taken effect immediately, you rather return a 202, which means the server accepted your request, and they still need some further processing before the outcome you wanted is actually going to take effect. In the case of something being created, you want to return a 201. You want to tell the client meaningful messages. You want to say, I've created the resource that you requested me to create, not just the 200 and then sending an error code or something to tell it, or informational code to tell it what really happened. Another important thing is the header. The header can contain useful metadata that can be utilized by the client. This includes things like media types, so the client understands how to process the content of the body. Caching metadata, security tokens. This all should be stored in your header, not in your body. Your body purely should be working with that resource that you're requesting. Now, something that's emerging and coming soon is HTTP 2. The whole point, I'm not going to go into depth into it, but HTTP 2 is going to make applications faster and more robust. And how it does this is using binary framing. So currently, text is sent over our networks. What this is doing is it's sending binary over our networks. The advantage is it can be compressed, and it's going to be a lot smaller payloads going over your HTTP protocol. This was spawned from Google's speedy experimental protocol. That's not spelled incorrectly. They just, and it doesn't stand for anything. They just decided to call it speedy, spelled that way. one thing to note is your existing applications will not be impacted. So unless you're building a browser or you work with applications dealing directly with your network layer, you're not going to be impacted by this change. However, if you are building a browser or something like that, you're going to need to cater for HTTP2 because the protocol is changing. So this diagram just shows you briefly what that does. In HTTP1, you've got your head and your body. This just gets framed into binary data and passed over the network. So I've just given you an overview of some architectural patterns and HTTP. Matt's now going to use some of that to explain RESTful architecture and the philosophies behind that.
Cool. Thanks, Rishal. Can you guys hear me? Cool. Yeah, so basically, as Rishal already kind of hinted at earlier on, REST is an architectural style. It's based on all of those architectural styles that we showed earlier, and basically where it comes from initially is Roy Fielding wrote a paper, quite a famous paper in 2000, in which he tried to document the architectural pattern that was used to build the web, basically. So it wasn't really invented from scratch. It was actually an effort to document kind of what was already being done, and providing that information to us so that we could use that same robust architecture in the stuff that we develop later on. So basically, he uses all of those different patterns composed into a new style to get a bunch of nice properties out of it. So just as an example of that, for example, he's using a layered system to make it easy to decompose your services into smaller components and to scale out. But because it's layered, you get obviously a performance hit, because now your request might be hitting this service, which is hitting another service, and so on and so on, which slows you down. So cacheability was then added on, to help compensate for that. So it's just kind of the logic behind it. So if you're going to be working with REST, there's basically a few fundamental concepts you need to know. The main ones are the concept of a resource, which is basically some entity that lives on a server, so a user account or information about a talk or a conference. Then a representation of that resource. So what we're sending across the wire when someone does a request is not the actual resource, it's just some rendering of that. And there might be additional information on the resource on the server. Yeah, so and then for anybody, I don't know, is anybody not familiar with REST? I guess hopefully everybody knows REST, so none of this should be news to you. But yeah, so a lot of people often try to compare REST and SOAP, which is a bit of a dumb thing to do because, like we said, REST is an architectural style. SOAP is actually a message-based protocol. It's a standard based on XML messages. So it's really not an apples-to-apples comparison. REST is a completely different philosophy almost of how to call remote services. So who knows about Hateoas? Everybody? There's only a few hands. Okay, so hopefully there will be some news here. Cool. So basically, I'm going to talk about the Richardson Maturity Model quickly. So basically, that was defined by Leonard Richardson in a talk a few years after REST came out. And in that, he basically just tried to guide people through what's a REST API and what's not a REST API. So he kind of goes through the different levels of not at all RESTful. It's like the swamp of POX, and then through the various enhancements that you can make to that API to become more RESTful. So the first level is the swamp of POX, or plain old XML. That's basically, you're just using HTTP for transport, if that's your idea of a REST service. It's basically calling something over HTTP by sending a message, and the server does something, and it will send back a response. And there's no pattern or logic to that. It's like XML. You've got this request message, means you're going to get some processing done that produces that response message. It's kind of like a pinhole into the API. You don't know what's going on in there. There's no pattern that you can discern. You're just told in the documentation, send this, you'll get this. So it's a bit crappy. So in this example over here, we're just sending a create question message, and that's sending us back a list of talk. Well, actually a talk with the questions on that, basically. So to then get a bit more RESTful, you can start talking to individual resources. So if you look at this previous slide, we've got kind of one endpoint over there, and that will have maybe multiple different things that you can do. So you could send different messages to that endpoint, and it will do a different thing. Once you start talking about resources, you start breaking your API up into separate parts. So you'd have a talks URI, which shows your talk resources. You'd have another one maybe for questions or another one for speakers. And what that does is it just helps you to decompose your API. Instead of having this one thing with hundreds of unknown operations, you actually break it down into smaller chunks with more well-defined operations. So going to the well-defined operations, you should be using HTTP verbs to do specific things to your objects. That way, it's kind of, there's no mystery to it that way. Like, if I have a resource for a question, there's a few obvious things I can do to it. I can go get it, I can go create a new one, I can delete it, I can update it, and there's standard ways of doing that. So it takes the guessing out of it, basically. It's just, okay, resource, do those operations, done. So there's just an example there. We're doing a get of talks. We're getting an empty list back. If we want to create one, we might want to do a post rather. Server says, okay, that's HTTP 201 created. It can tell us the location where that resource that we just created is living. So it's going to be a talks one. And in this case, it's giving us back the response body. All right. You could also, so in this case, let's go and we're addressing a different resource now. We're talking to talks one's questions. So it's a related resource basically. It's the questions for that talk. We're posting up a question. And in this case, just to kind of illustrate, it's returning a 201 saying we've created the resource, but you don't actually have to send back the representation of the resource. The guy just posted it up to you, so it's actually unnecessary. So you can save a few bytes by just saying, it's done, here it is, if you want to go get it later on, but you don't have to send it by default.
Yeah, but if your objects are really big, and you've got 100 fields in it, 50 fields in it, returning that back to the client each time they create it might slow down your service quite a bit. So just provide the client with a link, so if they really need to get it, it's just one more request to get it.
Yeah, and I mean, it's unlikely that it would have changed much since they posted it, and you just said we created it on the server, so they might store that link and later on go get an updated version, but right now it's unlikely to be different. Cool, so then to get into the Hateo stuff, so Hateo stands for Hypermedia as the engine of application state, and that's actually, according to Roy Fielding, one of the key things to a RESTful architecture is this idea that you should have links between your resources to make it an explorable API. I mean, that's one of the key things of the web. When you're in your browser, is you can open up a page and you can see, okay, I can go here, here, and here, follow the link, you get there, and from there go somewhere else. And that's one of the key things that are missing in most REST APIs, is that you can't do that. It'll usually be some documentation that tells you, okay, there's stuff here or there. But if you want to find out how to get the questions for a talk, you're probably going to have to go read some documentation. With Hateoas, the idea is to include that information in the response so that it's just a link that you can follow to go and get that additional information. So there's just an example. In this case, we're getting the root of our API, and it's sending back, okay, we've got an API, and it's got a few links. So we've got a link there for talks /API talks, and we've got a link for questions at API questions. So doing something like that, you can actually just go do a request to the root of the API and go, okay, this is the things that are present in here, and then follow the link. So if you go to talks, you might see that talks also have nested questions. This is just an example, I think, of getting, yeah, this is a list of talks. So in here we just got an actual talk. So this is something you'll see a lot with a lot of different REST message formats, is that they'll have a bunch of links possibly on an object. So in this case, we usually have a self-rel. That's actually the link to the object you just fetched. So again, that is useful if you want to maybe store that we're interested in this object, and later on we might want to go fetch it again. It's like a unique identifier, basically, in the form of a URL. And in this case, it's saying also there's a related resource, which is questions, which you can go get at the following URI. All right, so essentially the ideal REST API is a self-documented interactive service that uses the REST verbs and that you can interact with in a fairly standard and predictable way. Okay. Cool. So I just want to quickly talk about documenting REST APIs. Just because you're trying to design a self-documenting API doesn't mean you're not going to need any documentation. You probably still want to explain your domain or your reasoning to your users. So there's a few tools that seem to be kind of the leaders in that area, and those are Swagger and Raml. So basically, the two of them are very similar. If you look at the user interfaces, they look almost identical. Basically, Swagger's got Swagger UI, which is an interactive API documentation viewer. You can run that on a website, and people can actually go on there and type in requests and see how things work, play with it basically. And then you create your Swagger stuff by writing YAML specs. So, it's also got a bunch of additional tools. There's code generators and like a fairly large amount of different things that you can go do from a Swagger spec. On the Raml side, so just a bit of history, like Raml was actually created by, I think, the MuleSoft guys a little bit after Swagger. They wanted to create and design new APIs, so they went and they looked at Swagger and they realized that Swagger wasn't really going to work for them because it's designed for documenting existing APIs. So they actually designed Raml more to be a design tool as well. It's not just for post-facto documentation, it's kind of design your API, mock it out. So you'll see if I go into like the additional tools, they've got API mocking tools and stuff available for Raml. So you could design your API, mock it, and already start testing whether it's going to work for you. In terms of which one to use, I think go and do your research, decide which one's going to work for you. What I can say is that Raml does seem to have a few big names using it, so it seems like it might be winning. Cool. Then I want to go into message formats quickly. So another misconception people often have is that REST has to be JSON. As I showed in my earlier slides, that was not the case. When REST came out, JSON didn't exist yet. So initially REST was basically XML over HTTP. So basically, just comparing the two quickly, you guys have all seen XML. You know the good, basically you can do customizable markup. It's very mature. There's a lot of versatile tooling around XML. The bad is that it's very verbose. The standards are complex. There's like books full of standards that you have to go and understand to be able to handle XML and everything around it. And then the ugly, who's got multi-module Maven projects. Yeah, okay, you know the pain. It's not designed for humans. JSON, on the other hand, is a bit more friendly on the eye. What's nice about that is that it's very simple syntax. You've basically got just three concepts. You've got your scalar values, you've got arrays, and you've got objects, and that's it. If you can parse those three things, you can parse JSON. So it's really easy to parse. You actually don't need much tooling, so that makes it much more widely supported. The only downside, I guess, is that it's not as rigorous as XML or SOAP. There isn't XSD and stuff like that, for example, although there are a few standards that seem to be emerging around that, if you're interested in that. Then you can also get, in addition to just the basic choice between XML versus JSON, there are a few more specialized message formats that are designed for use with REST. One of those is the hypertext application language. So what that basically says is it's a standard way to format your JSON message for or your resource representation rather, so that you can easily go and get certain things out with your client-side API tooling. So basically what that does is you've got your base object, which contains all the old properties that you used to have. So for a user, maybe name, first name, email, whatever. It then in addition says that you have to have a link section, and the link section has to have a bunch of links in it that contain basically a rel, which is just a name for the link, and a href, which you'll follow to get to that. And then it also says you can have embedded resources. So where that's useful is if you've got something like a page of users, for example, you can actually have your page as a resource. The data on that page will be stuff like what page am I on, how many pages are there, how many resources are there, and then you'll embed inside that the actual list of users, which will again be full hell objects like that. So there's just an example of that. Basically you've got self-rel to say this is the user's resource, There's an operation you can do on it, which is next, which goes to page 2. So follow the link to get the second page of resources. And there's a custom operation, find, which takes a parameter that you can use to search for something. And this has got embedded in it a list of users. And then that's actually your base JSON object. So in this case, the resource we're looking at is a page or a collection of users actually, and we can see which page we're on and how many pages there are. Right. Another one that is also seems to be getting some use at least is JSON Schema. That's kind of like XSD for JSON almost. So that will basically let you specify a schema for your resource representation. So here we can say that we've got a person schema. The person is an object, so we're expecting a JSON object. It's got some properties, so we've got a name, that's a type string. We expect the guy to have a list of hobbies, which should have at least one item in the array. And we can say which of these fields are required. So this allows you to actually do some validation on a message representation to see whether the object is correct. Just comparison between the two. They're not 100% doing the same thing. JSON Schema is more aimed at validation, but there is an extension to that called, I think it's the Hypermedia extension for JSON Schema, which basically then kind of pulls it across into covering the same stuff as HAL as well. So that then says, okay, your resource representation should have a list of links and a list of embedded objects. So it actually does the same thing then and validation on top of it. Yeah, I think that's pretty much it. The main other thing just to note is that JSON Schema is tightly tied to JSON. So if you use JSON Schema, it has to be JSON. Whereas if you use HAL, you can still use XML message formats if that's better suited to what you're doing. Cool. So
just based on what Matt just said with the theory around REST and architectural style, we were just talking about you could build a service that works over FTP that uses steganography and images as the message format, and that would still qualify as a RESTful service.
You could still design it to be RESTful, yeah.
So
might not be very usable, but
the point I'm trying to make is that REST isn't the standard that everyone thinks it is. It's just a way of designing your services for certain benefits that provide scalability and cacheability, things like that.
Alright, so I'm quickly going to look at just a couple of ways of implementing REST services in Java. There's actually like a bunch more that we haven't even mentioned. So basically, if you've got an old existing Spring 3 project, I know there are still a few of those out there, I've seen them at my clients, and you want to start adding a REST service, it's pretty simple. You're just going to do straightforward MVC, so you're just going to have a normal controller. The main difference is that you can then return your resources using an @response body annotation, which just says go and serialize this out in whatever message format I'm using. So that'll by default I think be JSON with Jackson. If you're on a Spring 4 project, you get just a small convenience in the form of the REST controller annotation. If you put that on your controller class, then you don't need to go put the response body on each of your requests. That's implied then, so it's just a small convenience. So that comfortably gets you up to about REST API level 2. So you can do your basic operations, your verbs, unique URLs for all your resources. If you want to do Hateos on a existing Spring MVC project, there is actually a library for it called Spring Hateos, which basically tackles the problem of adding links to your representation. And you'd think it's not that difficult, but there is actually quite a few bits and pieces to it. So I'll quickly show that to you guys. It basically adds models for your links and your resource representations. So if you have a look at this bit of code over here, basically it's saying that we're creating a link to some resource. And what that'll do is if you go look at that link object, it basically has that rel and the link, the href in it that we showed earlier in our responses. So it's just that model object basically. If you want to create one with a custom rel, you just pass that in. Then in terms of the resource representation, it's got a resource support interface. So what that does is it just makes your resource representations aware of the fact that they can have links. So it gives you basically a list of links, and you can add your links to that object then when you're rendering it out. The next one they've got is they've got the link builder. So the link builder basically helps you to construct these links. So there you can basically go tell it that we've got a question controller and we want to link to that with rel questions. So what that will do is it'll go use the annotations to see what the context path would basically be that's exposed by that controller. So API/questions or whatever, and it will basically construct the link for you with the correct role. You can then also do it with a specific ID. So down here, if you pass in an ID, you can say I'm linking to question 42. So it will then include that in the link representation that gets rendered out. So link would look something like that. Linking to resources by ID can be simplified a bit. If you extend your models with implement the identifiable interface, you can actually go tell it what getter to use to get your ID out, and in that case you then don't have to manually go do get ID, pass it into a link every time. You can just tell it link to this thing and it will figure out what the ID is and show it for you. One thing that does get a bit nasty is that if you're now doing this, you might end up like in my user I'm referring to conference, and I've got all of these static conference controller references, which is not very nice. So what they also added is they've got entity links, so you can actually in your configuration go say enable entity links, and then you can auto wire in an entity links object, which basically just holds a map of all of the resources that you're exposing, and then you can use that to construct your link by just telling it I want a link for a user and there's the ID. And that way you then don't have to have that hard reference to the other controller in there. To make that work, you just have to add exposes resources for to all of your controllers, and that basically registers it with the entity links object. Cool. Then the last bit is just resource assemblers. So resource assemblers basically just take care of converting your domain model object into a resource. So it's just a standard interface for doing that. This makes you that code in a standard place basically, and then Atheos uses that. Cool. So yeah, I think that kind of covers Spring Web MVC Atheos. If you've got, so that's if you've got an existing project. I've built an API with that. It's still, even with the support from Atheos, it's a fair bit of work that you have to go do. If you have the luxury of being on a new project that's Spring 4, you can actually use Spring Data REST. So Cornel presented on Spring Data yesterday, so you guys have seen that stuff, where you basically just write an interface to create your repository layer, and Spring Data REST builds on top of that by basically just exposing all of the CRUD operations on that resource repository as a REST API for you basically. So this is quite easy. You basically just need to configure it. So if you're using Spring Boot, you can basically just set the base path API to tell it what the root of your API is going to be, and then without boot, you need to do a little bit of Java config to basically go do the same thing, not too complicated. You then need to have, either an existing or a new Spring data store. So I'm going to use JPA for the example. So essentially the part that you see down there, the interface, that's just Spring Data JPA. So we're just defining a repository that's going to expose a list of questions. And we've got a single custom operation on that, which is to search by some parameters. So it's probably just going to do a full text search. The only part that data REST then adds is just this part at the top to say this annotation at repository REST resource, where you just tell it, if I've got a rel referring to a question, use the rel questions. So that's for the link generation. And then the path, it just says it's going to be at our base path / questions basically. So that's the only additional configuration. After this, you can pretty much start up your application and start doing requests on your question API. So that is super easy to get started with for basic CRUD operations. Yeah, so I think that's pretty much just another example. So yeah, I think that was just basically a brief introduction. That's like a couple of very Spring specific ways to do it. Obviously there's a bunch of other libraries and technologies that you can use. So JAX-RS, there's Play framework, I think, is pretty much predicated on building RESTful APIs as well. So there's a lot of other tools that you can use. This was just kind of a taster for what you can do with Spring. Yeah, and then I think Rishal's going to talk a bit about consuming REST services. Thanks.
Cool. So Matt gave you an overview of the REST paradigm as well as how you'd possibly build one with the Spring framework. I think that Spring data REST, with Spring 4, that's really cool. I mean, with minimal code, you get a REST service out of the box, which is really awesome. And that's a REST level 3 in the maturity model. That's really cool. So I'm going to talk a bit about consuming these REST services now. So there's so many clients out there, browsers, mobile, etc. How do we now consume the data and consume these services once we've built this awesome REST level 3 API? So when consuming a service, you need to be able to do three things. You need to be able to make requests, typically HTTP. So although REST is not tied to HTTP, the internet runs on. So typically an HTTP request, you need to be able to accept a response, and you need to be able to interpret that response. And preferably be able to serialize and deserialize the body so you don't have to go and mess with those text responses. So one way we can do this, and if you have an explorable API, is with Postman. And this is typically used for testing, and it could even act as live documentation for an API. You might have used it before. It's a Chrome plugin. What it lets you do is it lets you set up requests that you're making to your service, save them. You can replay batch requests. You can use those same batch requests on different environments. For example, on your dev, QA, UAT environments. And it also has some awesome authentication helpers that makes it really easy to explore an API. So that's generally what it looks like. If you haven't used it before, I suggest just getting the Chrome plugin and playing around with it. It's a really cool tool. Now we live in a world where JavaScript is emerging quite a lot, and you want to consume your RESTful API with JavaScript. So you're going to have to do something like this every time you want to make a response, a request. So you'll need to send everything that it needs, including content type, the connection. You need to manage all of that yourself. So rather use a library that's going to help you with it. So one of the libraries that is widely used is jQuery. jQuery makes it really easy to to consume a service. All it is an AJAX request. So make a request to a resource and process that request once it's returned. And you can access that as an object. So ID and content are just properties on that object that you receive. So jQuery is also getting dated. The new fad is Angular.js. So if you haven't heard about Angular.js, it's a front-end web framework for single-page applications. It's built on HTML, CSS, and JavaScript, and it's an application that runs in your browser. Now, with Angular, your content is served independently, your application is served independently from your data and content. The content is retrieved when it's needed. So this is how typical web applications work. The client will make a request to the server and will respond with an HTML payload that's populated with all your data and all of your fancy theming and everything. However, with Angular, your initial load loads up the Angular application. So one of the disadvantages of Angular is if you have a really big application, that initial load is going to be quite a heavy download for the client. But thereafter, every response and request is just JSON. It's small requests and responses to and from the server and client, and it makes it a lot more lightweight. But obviously, you'd use or not use Angular depending on your project, depending on your context, depending on your requirements. So Angular makes use of an MVC design pattern. You have your web service, which passes models. It's got a concept of a controller, and that binds a model to the view. So whenever this model in the controller changes, it's bound to the view, and if you code your app right, it'll be bound to the service as well, which makes for really great real-time applications. This is great for things like dashboards. So if you're building an interactive dashboard, we need real-time updates. You want fancy stuff on it. You'd want to use Angular. So if you want to get started with this, you're going to need to get Node installed, preferably a good IDE. We're fanboys of JetBrains, so WebStorm or IntelliJ. And then for building and dependency management, these tools are like the Maven and Gradle in the Java world. So Grunt and Gulp will help you with your build process and making sure that your JavaScript that you're writing is clean and will work. Since JavaScript isn't compiled, it's interpreted. And then your dependency management is with Bower, NPM, and there's a host of new ones out there, Browserify, and you can go and have a look and see what suits you best. Now, what Angular did for consuming REST services is gave you two options. There's $HTTP. Now, $HTTP is the core of Angular's communication with the HTTP protocol. So, here's an example. If you want to make a request to some URL, there's the callback for the success function, and there's the callback for the failed, if there was a failure. Similarly with the post, same thing, you'll provide a URL, but this time you're providing a message body. In this case, it's in the form of JSON. But now we can't work like that. We can't do that for every single thing we want to do. It's going to be a lot of code. It's going to be very tedious. So what Angular did is they provided $resource. So $resource is a factory which creates a resource object that has a template adapter for all of your CRUD methods. So your get, your post, your put, your delete, all of that stuff is handled by this adapter. $resource has a dependency on HTTP, since HTTP is the core access to the network, and it also uses ng-resource. You need that module installed. So this is basically what it does. It allows you to specify what each of the HTTP operations are going to map to in terms of your Angular project. So if for some reason you want to name them differently, more meaningful, so perhaps save instead of post, you can do that. So in this example here, you'll see with this one line, I've created a template to do any interactions with that resource on the RESTful service. I'm telling it it's user, and I'm telling it that that's how the ID is specified. And right here, I'm getting a user, I'm changing ABC to true, and I'm doing a set. And in this in the background is doing all of the HTTP calls that I would have done manually. Now, if you want to add a custom operation, it's really trivial. Similarly, you'll create the definition for that resource, and you just add on what operations you want to add. So in this case, it's a post operation with these parameters, and it's going to be called chart. So right here, you'll see we're getting all the cards. We're getting the first item in that list. We're changing the name. We're saving it, and then we're charging them 9.99. So in summary of this, HTTP is used for non-REST APIs. If you're going to use it, it's going to be used for interacting with APIs that aren't at least REST level 2. If you're going to be using $resource, your RESTful API needs to be at least level 2 or above. Now, in the world we live in, mobile is a big thing, so I'm going to talk to you a bit about Android. So Android, if you don't know, is a Linux-based operating system for mobile. The SDK is Java-based, so if you know Java, you don't necessarily know Android, but you can learn it.
Definitely not.
And what's interesting is there's 2 runtimes, so this isn't really related to REST. I just found it an interesting tidbit. The Dalvik runtime, which is a just-in-time runtime, it's based on an old Apache project. I forgot the name now. And the new one's the Art runtime, ahead of time. So this tries to compile things ahead of time based on the user's activity, which is, I think, is pretty cool for optimizing your apps. Okay, so if you want to get started with Android, it's pretty simple as well. You need the JDK, Android SDK, a good IDE, and you can use some of the tools that you already know, preferably Gradle instead of Maven. Maven can be very painful with Android. We know this from experience. And there's cool tools like Genymotion for emulating different devices. The out-of-the-box one is good, but not as good as Genymotion. All right, so some hiccups you can run into with Android is you might have your code and you're confident it works, but it just doesn't pull or doesn't run. The Android manifest requires an internet connection. So if you're consuming a REST service, please make sure that's the first thing you do. Otherwise, you'll sit there for hours wondering why your app's not working. Also, network tasks cannot be on the main UI thread. So you need to create async tasks or background services to perform your network operations. And this is because Google don't want to diminish the user's experience because of your network activity. So you need to be smart about the way you use the network and how you represent that on the front-end UI. So if you're consuming a RESTful service with plain Android, it's also a very manual process, but it's not too bad. You provide a URL, you create a connection. The problem is you need to now deal with an input stream and parse that input stream and figure out what the response was. You can deserialize the response with this whole bunch of code here. But why would you want to do this all manually? So one of the cool libraries out there is called Retrofit. You might have used it before. What's really great about Retrofit is it's not specific to Android. It can work in any Java project. So Retrofit is a client, RESTful client for any Java project. And this is basically how you set it up. This is the only configuration you need. You set up your base path for your RESTful API. You set up an adapter with that endpoint, and it will build your client for you. And this is how you'd use it. There's no implementation, it's just interfaces that you write. So in this case, there's an interface, and every method signature on here, you can specify what URL it maps to on the RESTful service, as well as the parameters it takes in. Cool, so this is how you access your API. Now you've got that RESTful adapter, you want to create something of that type, and that's it. So this is very similar to Angular's $resource, where it has a templated approach, and it makes life for you really easy as long as your RESTful service is of a fairly mature state. Again, REST level 2 or above.
Yeah, something you just mentioned about Retrofit as well is it's not just for Android. You can actually use it anywhere on your desktop clients, wherever. So you can actually write your API binding basically once and reuse it on desktop and Android applications.
Okay, so in summary, why would you want to build a RESTful service? Well, it's scalable, it's fault tolerant, it's recoverable, and it's loosely coupled. So there's no such thing as a session, and the session's in a weird state. Everything's small atomic operations that are very lightweight and very suited for the clients that we work with now, the browsers and the mobile devices and things like that. So in summary, REST is a huge topic. We've been through just a few points here, and I'm sure some of you might feel a bit overwhelmed about the number of different approaches and libraries and concepts encapsulated in this topic. So we just gave you a taste of what's involved, and we recommend you go and do some research and learn a bit more about what REST actually is and what the architectural style is before or while you're embarking on your next project. Cool, thanks.
Thanks, guys.
Are there any questions?
Can you go through how you can grow your maturity of REST API? So if you're sitting at REST level 2, how do you get to level 3? Do you have to redo the whole thing, or can you
Or
kind of adapt
you
your
just
current system?
you basically just need to add the links to it if you're already at level 2. So you essentially just need to add some additional code to figure out what is the link to a resource and just render that out. So going from level 2 to 3 is in theory quite easy.
Well, I also think it depends on the current code base, what condition it's in,
Yeah, I
and how
suppose
you
so.
designed it. But essentially, REST level 3 is making your API explorable. So if you could write some adapter that just interfaces with your existing entities and can add the links to make it explorable, you'd be on REST level 3.
What approaches are there to securing your REST API from unauthorized access?
Okay, so basically we're securing a REST API. Yeah, so the main way that I've seen used is basically a token-based system. So what you would do is you would still have some kind of a sign-in type method where you sign in, and then it actually returns in response to that a secret token that you then include in the headers. And that token is then essentially used as a authentication mechanism to say this is the user, they have these permissions. In terms of keeping that secure, it usually uses very short lifespans for which those tokens are valid. And then I think you could also probably use OAuth as well as another way.
Yeah, and also I've seen uses where you're provided with an API key.
Yeah,
So,
so it's a token I was talking about.
you
Yeah.
can be provided with an API key and use that for your calls
Right.
without having to sign in to the RESTful service. But in our experience, where we've built a few of these, we're working with clients where they have existing Active Directory authentication. So we have to sort of work with that and build on top of that.
Yeah, another one is we've got projects where we're kind of running a MVC application that also has a REST API, so it's a normal session-based application actually in that case. And then you can sometimes actually just piggyback on top of the normal cookie-based session authentication that you've already got.
So I think with Spring, if your config is right, you can still make use of your Spring security configuration in your RESTful API, even though it's logically separated from your normal Spring MVC project that serves users.
Okay, and then just a second question, suitability of REST for communication among microservices.
Can you elaborate?
So your communication protocol to talk one microservice to another using REST, rather than, the typical use case is you've got a front end and there's a client connecting to it, but now your microservices are talking between each other using REST.
I think I don't see why not. I mean, because you've got cacheability and stuff like that, that means that if you know that the response I'm giving out is going to be maybe valid for some time period, you can mark that as cacheable, and you actually get performance gains out of it. So I think the principles, architectural principles of REST should make perfect sense with microservices, I think.
Right, so I'll just add a comment and a question. So my comment is on the using REST for microservices. We at DSTV use that quite extensively. We haven't had any problems. You get the advantage of the caching, the ease with which people can integrate to your services as well. Makes it a pretty good option. And then my question is about the level 3 of the maturity model and HTOS as well. If I am understanding what you guys are saying correctly, the only advantage to getting from level 2 to level 3, or the only advantage for using HTOS is that the service becomes kind of explorable. So that's great for developers who want to integrate with your stuff, but it's not very useful unless you write like some AI client
Yes, so you could.
So I mean, is it just a question of ease of documentation and explorability, or are there any other advantages?
Well, who's going to use your REST service if not other developers?
Yeah, so well, I guess that's one answer. In terms of kind of having those links available, it does actually allow you to have clients that are more automated, that might be able to do some processing on the representation that's coming back and conditionally decide, oh, I need to go get something else as well. So I do think there is some benefit there as well if you are going to do something advanced.
Okay, I think just to Rishal's point, I think my question is driven more about like the cost versus the benefit.
Okay.
The cost is like all that stuff that you guys were showing of, adding all that stuff with Spring, and I think Matt, you did also mention that it is a lot of work.
If you do it with Spring Hateos, it is a lot of extra work. That is definitely true. On the project where I did build it kind of by hand, I did feel that it was worth it though, because we had a lot of cases where it was kind of separated between two contractors. So we were doing the API and the other guys were doing the front end client, and then the client would go to them like, oh, can't you just show this user's account details on this? And they're like, okay, now you guys need to give us a new method. And we're like, no, we don't. You've got the user, just follow the link, go get the account details, and there you go, you've got it available. So it makes it very easy to just kind of find what you're looking for. So I think that is quite a good benefit. And just, it kind of standardizes what you can do with it. So, if you're using something like Hell, you can actually write client code that is fairly standardized, because it's going to interact with all resources in the same way. So, yeah.
Just a comment, so you're talking about the cost versus the benefit. I think that's also very dependent on your situation and your project. So if you're starting a new project, it's really easy to get that stuff in. But if you're currently working on a project that's been in development for a while, there's a known set of users, they're integrated with that API, it's documented and everyone understands it. Maybe you don't want to spend 2 months getting into REST level 3. It doesn't make any business sense. They're not getting any value from it. But maybe down the line you encounter a need for it, then it might be worth the investment. So I think, you can't really definitely say if it's worth the time unless the requirement says it's worth the time.
Judgment call on the project, yeah.
So to add to that, at Rubyfruiter there was a lightning talk showing somebody who built in Ruby some front end, the name escapes me unfortunately, but where it would kind of style your forms and give you an explorable form driven thing where you could add to that. So how useful that is, I think it's probably really constrained to a few things, but you can build kind of explorable stuff where you can enter things and kind of keep going and going and going. So yeah, those things are there. But yeah, the one thing there also is, I think, was you mentioned Swagger as well, because I think in a way for me trying to understand Swagger, that was also the problem, because Swagger seems to be pretty much assuming that you don't have links and you don't explore, and it's very fixed. So in terms of documentation, in terms of documenting existing things of your level 2 API, that might be the easier approach to just document things.
Yeah, I mean, adding Swagger is far quicker than changing your API to be REST level 3 compliant. So that could be one route to solve that problem.
What about outing, since we've mentioned Spring Data and Spring REST a couple of times yesterday and today, that when you use Spring REST, it can actually infer some of the hyperlinks based on JPA metadata annotations. So the cost might not actually be as high as you think, provided you
more questions? Okay, I have to do this. Matt's wife got me into this. It's Matt's birthday today.
I thought you forgot.
And she asked me to ask you guys to sing happy birthday to him, and so I can take a video of him for her. You guys keen for that?
Yeah. Yeah.
Cool. Let's go.
Happy birthday to you.
Happy birthday to you. Happy birthday, dear Matt. Happy birthday to you. Hip hip. Hip hip. Nog hip hip. Thanks guys.